Welcome, my dear learners, to another interesting episode on Civil Tutorials. In today's lesson, we are looking at a new topic altogether, and we are starting with what we call number bases. Number bases. But before we start our lesson, as usual, we have to look at the lesson objective for the day. So at the end of this very lesson, you, my students, should be able to convert base 10 numerals to other bases and vice versa. This is what you must know and do at the end of this lesson period. So without wasting time, let's start. But if you are new on this very channel, kindly like, share, and most importantly, subscribe to this very channel for more updates. So let's start. Number bases. Usually, numbers are written in base 10. Examples of these numbers are what we already know. So examples of such numbers are, let's take it that you have 12, 24, 36, 81, and so on and so forth. Now, when a number is written without the base assigned to it, we assume that that number is written in base 10. So when you look at this example, you realize that there are no bases attached to these numbers. So we assume that these numbers are written in base 10. When the base of a number is attached to the number itself, it is written as a subscript to the number. So let's say that you have a subscript x. Now a is the number and x is called the base of the number. So example, when you have a number, let's say 1011 subscript 2, this basically means that this number is written in base 2. Are you following? Also, when you have a number such as 233 subscript, let's say 4, this basically means that this number is written in base 4. Similarly, when you have a number, let's say 4, 3, 5 subscript, let's say 8. What does this mean? This means that this number is written in base 8. Are you getting the clue? Good. The highest digit in every number base is 1 less than the base itself. The highest digit in every number base is one less than the base itself. So a base 2 number. So base 2 number has 2 digits ranging from 0 and then 1. So you realize that the highest digit, which is 1, is less than the base itself. So when you have a base 4 numeral, a base 4 numeral has 4 digits starting from 0, 1, 2, 3. So you can also see here that the highest digit, which is 3, is 1 less than the base itself, which is 4. So when you have a base 10 numeral, a base 10 numeral has 10 digits ranging from 0, 1, 2, 3, up to 9. So the highest digit, which is 9, is 1 less than the base itself. Now let's look at a base 12 number. Base 12. A base 12 also has 12 digits, starting from 0, 1, 2, 3, 4, up to 11. So let's say 10 and then 11. In number base, 10 is represented as T, and then 11 is represented as what? E. Now that we understand what number bases are, let's look at some special names given to number bases and their special name given to them. Now, a base 2 numeral is called a binary numeral. A number that is written in base 4 is called a quaternary numeral. A number that is written in base 6 is called a sexamal numeral. Sexamal numeral. A number that is written in base 9 is called nonary numeral. Nonary. A number that is also written in base 8 is called octal numeral. A number that is written in base 10, which is the common among all the number bases, is called a decimal numeral or a denary numeral. There are a lot of special names given to different number bases. Kindly go and then search for them. Is that clear? Good. Now that we understand number bases now, we are going to learn how to convert these number bases from one base to the other. We are going to learn how to convert from base 2 to base 10 and vice versa. We are also going to learn how to convert from base 10 to other bases. This is what we are going to do. So let's start from converting from base 2 to base 10. Is that clear? Good. So we have our first example. We want to convert 101 subscript 2. This subscript 2 means that this number is written in base 2. We want to convert this base 2 numeral to a base 10 numeral. So that is what we want to start with. Converting from base 2 to base 10. Okay. So let's write our solution. Now in converting from base 2 to a base 10 numeral, or converting from other bases to base 10 numeral, now this is how we are going to do it. Just follow the steps and it is very, very simple. So first we are going to write down the number 101 base 2. Now what we are going to do is that we are going to write this number 101 as seen here in order. So we are going to write 101. So this number is what I've written down here. Now the next thing that we are going to do is that we are going to multiply each of these number by the base given, and then we sum them together. So we are going to multiply here by 2. We sum them, multiply this number by base 2. We sum them, multiply this number by 2, which is the base. We sum them. Now the next thing that we are going to do is that we are going to start counting from the right to the left. So we are going to start counting from the right, the extreme right, to the left on top of the number bases. And the counting starts from where? 0. So we start from 0, 1, and then 2. Now what is left is simplification. Okay, so we are just going to simplify what is here. Now 1 times 2 power 2 give us what? 4. Plus 0 times 2 power 1 is what? 2. Plus 1 times 2 power 0 is 1. Any number raised to the power 0 is 1. So 1 times 4 will give us 4, plus 0 times 2 will give us 0, plus 1 times 1 will give us 1. The rest is addition. So 4 plus 0 plus 1 will give us 5. So therefore we can say that 10101 base 2 is equal to 5 base 10. Very, very simple. You see how simple it is? We take the next example. It is your example. Pause the video and then you solve it. So your example is convert 1011 base 2 to a decimal numeral. Try your hands on it. So I guess you were able to solve it. Let's solve it together, okay? So we have our solution. So we are going to write our number 1011 base 2. So as I said earlier on, we are going to write this number in order here. Okay, so we have 1, 0, 1, 1. Good. So the next thing is we are going to multiply each of these numbers by the base given. So the base is 2. So you multiply each of these numbers by 2 and then we sum them. Multiply each of these numbers by 2, we sum them. Multiply by 2, we sum them. Multiply by 2, we sum them. So the next thing is we start counting from the extreme right to the left. And the counting starts from what? 0 on top of the number base. So we have 0, 1, 2, 3. The rest is simplification of these numbers. So we have 1 times 2 power 3 means 2 times 2 times 2. 2 to 4, 4 to 8. So we have 8. Then we have plus 0 times 2 power 2 means 2 times 2. And this gives us 4. Plus 1 times 2 power 1 is what? 2. And then 1 times 2 power 0 is 1. As I said earlier on, any number to the power of 0 is 1. Okay, take note. So we have 1 times 8, we have 8. Plus 0 times 4 will give us 0. Plus 1 times 2 will give us 2. 1 times 1 will give us 1. So this gives us 8 plus 0 plus 2 plus 1, 10, 11. So it gives us 11. So therefore we can say that 1011 base 2 is equal to 11 base 10. Very simple. And I guess we're able to get 11 base 10. We take the last example on base 2 numbers. Try your hands on it. So this is your try work. Convert 100,101 base 2 to a base 10 numeral. Try your hands on it. I hope you are done. What did you get? Write it down and let's solve it together. So we have our solution and then we have our number base, which is 100 100,101 base 2. So we are going to write this number in order. So we have 1 0 0 1 0 1 0. Let me clean this part. 0 1. So the next thing is we are going to multiply each of these numbers by the base, which is 2. So multiply here by 2. We sum them. 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 And then multiply the last one by 2. And then we sum them. So the next thing is we are going to start counting from the extreme right to the left. And the counting starts from where? 0. Good. So the rest is simplification. So we have 1 times 2 power 5. So 2 power 5 means that 2 multiplying itself 5 times. And 2 power 5, we have 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 2, 2, 4, 4, 2, 8, 8, 2, 16, 16 times 2, we have 32. Then we have plus 0 times 2 power 4 will give us 16 plus 0 times 2 power 3 will give us 8 plus 1 times 2 power 2 will give us 4 plus 0 times 2 power 1 will give us 2 plus 1 times 2 power 0 will give us 1. So we have 1 times 32 will give us 32 plus 0 times 16 will give us 16. Sorry, to give us 0 plus 0 times 8 will give us 0. 1 times 4 will give us 4. 0 times 2 will give us 0. 1 times 1 will give us 1. So we have 32 plus 4 give us 36 plus 1 give us 37. So therefore we can conclude and say that 10101 base 2 is equal to 37 base 10. I guess you have this number. Now let's look at another aspect, one that involves decimal. The one that involves a decimal. How do we go about it? So we have example 4, right? So we have to convert 1.1 base 2 to a decimal numeral. we have to convert 1.1 base 2 to a decimal numeral. You realize that we have a decimal point within the number. How do we go about it? Now, its procedure is quite different from this one, but it follows somehow the same. So let's go through and then see how it goes. So we are following the same procedure. We have 1.1 base 2. So with this also, we are going to write the number as seen. So we have 1 and then 1, isn't it? Then the next thing that we are going to do is we are going to multiply each of these numbers by the base. Okay, when we are writing it, please don't bring the dot sign. Okay, don't bring this one, the dot. Just write it 1 1. Just write the number without a dot. Okay, and then the next thing, we are going to multiply each of these numbers by the base. So the base is 2. We multiply this number by the base. We sum them. Multiply this number by the base. We sum them. I hope you are following. Now what we are going to do next is we are going to start counting. But with this one, the counting is not going to start from the extreme right. The counting is going to be from the number before the decimal point and then the number after the decimal point. That is how we are going to count it. So in counting it, the number in front of the decimal point is 1, which is this one. So we are going to start counting from this part up to this very part. Okay, so the counting starts from 0. And then we move on to the number behind the decimal point. So the number behind the decimal point is this number. So we are going to start counting from this number up to the right. Okay, but the counting starts from -1. That is very important. You have to take note. The counting starts from what? -1. When you are counting behind a number behind the decimal point. So we are going to write here -1. So assuming that you have 1 point, let's say 011. Okay, it is in base 2. So when we are counting, it is going to be -1, -2, -3. Are you getting the clue? Or it is going to be, let's say, 0 times 2, which is the base, -1 plus 1 times 2, -2 plus 1 times 2, -3. That is how we do the counting of numbers behind the decimal point. Go. So let's do our simplification. We have 1 times 2 exponent 0 will give us 1. And then we have 1 times 2 exponent -1. In indices, when you have a number raised to a power of negative, is the same as 1 over the number. Okay, so when you have 2 exponents -1 is the same as 1 over 2. So 2 exponent -1 is the same as 1 over 2. Good. So 1 times 1 will give us 1 plus 1 times half will give us what? Half. So 1 plus half is what? 1 whole number, 1 over 2 or 1.5. So therefore we can say that 1.1 base 2 is equal to 1.5 base 10. Very, very easy. Good. I'll give you one try example on the decimal aspect and then see if you have equally grasped the concept. Okay. So you try your hands on this and then we move on to another aspect. So I guess you were able to convert it to base 10. Let's see if you are on the right path. So we have our solution. We are going to write our number 10.11 base 2. So we are going to write this number here. So we are going to get 1, 0, 1, 1, 1. So the next step is we are going to multiply each of these numbers by the base given, which is what? Base 2. So multiply here by 2. We sum them, multiply here by 2. We sum them, multiply here by 2. We sum them, multiply here by 2. Now the next thing that we are going to do is identify where the decimal point is. So this is the decimal point. Let's identify the number before the decimal point. So the number before the decimal point is what? 0. So let's identify it here. So this is the number 0. So let's make some stroke here. So after identifying that number, we start counting from right to left. And then after doing that, we identify the number behind the decimal point, which is 1. Then we start counting from right to left. So in doing so, we are going to start counting from 0 and then 1. But behind the decimal point, we are going to start counting from -1 to negative infinity. So we are going to get -1, -2. If we were having an additional number here, it is going to be -3, and so on. So that is how it is done when you have a decimal number. So we are going to simplify. So 1 times 2 power 1 will give us 2 plus 0 times any number raised to the power 0 is 1 plus 1 times 2, as I said earlier on, 2 exponent -1 is the same as 1 over 2 in indices, negative reciprocal. So we have 1 over 2 and then 1 times 2 exponent 2 exponent -2 is the same as 1 over 2 exponent 2 indices. So we have 1 over 2 exponent 2. 2 power 2 is what? 4. So we have that. So let's simplify. 1 times 2 will give us 2, plus 0 times 1 will give us 0, plus 1 times half will give you half, plus 1 times 4 will give you 4. So we have 2 plus 0 plus 1 over 2 plus 1 over 4. So 1 over 2, so let's have it here. 1 over 2 plus 1 over 4. We have 4. 2 into 4, 2. 2 times 2, 2 plus 1. We have 1. So we have 3 over 4. So we are going to get 2 plus 3 over 4. So we are going to do this also. So let's solve it here. 2 plus 3 over 4. You find the LCM, which is 4. 1 into 4 is 4. 4 times 2, we have 8. 4 into 4, 1. 1 times 3, we have 3. We have 11 over 4. So we can say that 2 plus 3 over 4 will give you 11 over 4. So therefore, we can say that 10.11 base 2 is equal to 11 over 4 base 10. Over 4 base 10. Very, very simple. Good. Now the next thing that we are going to do is we are going to learn how to convert from other bases to base 10. Other bases to base 10. That is what we are going to do. So let's make more progress, converting from other bases to base 10. So we are going to learn how to convert from other bases such as base 4, base 5, base 6, other bases to a decimal numeral or base 10. Now in doing the conversion from other bases to base 10, it follows the same procedure like the one we did previously, converting from base 2 to base 10. So converting from other bases to base 10 follows the same method. Is that clear? Good. So let's take the example and then try our hands on it. We have to convert 233 subscript 4, which means that this number is in base 4. We have to convert it to a base 10 numeral. So as I said, it follows the same approach. We are going to write our number 233 base 4. So what we are going to do is we are going to write the number here, okay? So we have 2, 3, and then 3. So the next thing is we are going to multiply each of these numbers by the base given. So multiply here by, let me use by 4. We sum them, multiply here by 4. We sum them, multiply here by 4. So the next thing we are going to do is we are going to start counting from the extreme right to the left, starting from where? 0. So we are going to start counting from 0. So we have 0, 1, and then 2. So the next thing that we are going to do is simplification. So we have 2 times 4 power 2 means that 4 times 4. 4 times 4, and that is what? 16. So we have 16 plus 3 times 4 power 1 will give us 4. Then we have 3 times any number raised to the power 0 is 1. So we have 2 times 16 will give us 32. 3 times 4 will give us 12. 3 times 1 will give us 3. So we have 32 plus 12 will give you, we have 44, right? 44 plus 3 will give you 47. So therefore we can say that 233 base 4 is equal to 47 base 10. Isn't it simple? Very, very easy. I'll give you one example. You try your hands on it, okay? So this is your try example. Try your hands on it, and then let's see what you are getting, okay? So let's solve it together. So what we are going to do is we are going to write this number here. We are just going to repeat it. So we have 2, 3, 4, 2 base 5. So as I said earlier, we are just going to write this number as written here at this very side. So we have 2, we have 3, we have 4, and then we have 2. So 2, 3, 4, 2. Good. So the next thing we are going to do is we are going to multiply each of these numbers by the base given. So the base is 5. So we multiply here by 5. We sum them, multiply this number by 5. We sum it, multiply this number by 5. We sum it, and then multiply this number by 5. We sum it. So the next thing that we are going to do is we are going to start counting from the extreme right to the left, starting from 0. So we have 0, 1, 2, and then 3. So the rest is simplification. So we are going to get 2 times 5 power 3 means that 5 times itself 5 times. So we have 5, 5, 25, 25 times 5, we have 125. So we have 125 plus 5, 3 times 5 over 2, which means that 5 times itself 2 times. So 5 times 5 will give us 25. So we have 25. Then, sorry, we have 3 times 25 plus 4 times 5, we have 4, sorry, and then times 5. And then we have 2 times 5 raised to the power 0 is 1. So 2 times 125 will give us 250. 3 times 25 will give us 75. 4 times 5 will give us 20. 2 times 1 will give us 2. So the rest is just addition and subtraction. So we have 250 plus 75 plus 20 plus 2. So let's do it. We have 250, we have 75, we have 20, and then 2. This is what 250. So we have 0 plus, this one will give you 7. 5 plus 7, we have 12 plus 14, 1. So we have 347. 347. So therefore we can say that 2, 3, 4, 2 base 5 is equal to 347 base 10. And that is very, very simple. I'll give you one. Try example. You make sure you solve it, okay? So try your hands on this. So I guess we're able to convert it to base 10. So let's solve it together. We have our solution. So we have the number ET6 base 12. So we are going to write this number in order. So we have E, T, and then 6. But remember, in our introduction, I said that the letter E in number basis means 11. And then the number T in number basis means what? 10. Take note. So we are going to multiply each of these by the base given. So we are multiplying here by 12. We sum them, multiply here by 12, multiply here by 12. So the next thing is we are going to start counting from the extreme right to the left, starting from 0. So we have 0, 1, and then 2. Very good. So we have E means 11, right? So we have 11 times 12 raised to the power 2 is 144 plus, as I said, T in number base means what? 10. So 10 times 12 power 1 is 12 plus 6 times 12 raised to the power 0 is 1. So we have 11 times 144 will give you 1584 plus 10 times 12 will give you 120, and then 6 times 1 will give you 6. So when you punch your calculator, I think you are going to get 1710 and then base 10. So we can therefore say that ET6 base 12 is equal to 1710 base 10. Very, very good. So this brings us to the end of today's lesson. I'm going to give you extra set questions. Make sure you pause the video and you write them down. As I said, if you are new on this web channel, kindly like, share, and most importantly, subscribe to this web channel for more updates. So these are tutorial questions. Pause the video, you write them down, and then you try your hands on it. See you next week. Bye bye.